Welcome one and all. Here we will discuss problem number 26 of exercise 5.1. Here they are stating find the values of k so that the function is continuous at the indicated points. So indicated point here x is pi by 2. So we have to say the function is continuous. They are asking us to assume the function is continuous at pi by 2. If the function is continuous at pi by 2, what about the possibilities of k? Okay, so we know each radian measure has been mapped with one real number. The function has been defined for all real numbers. Whenever the value of x is not equal to pi by 2, we will have the function as f of x as k cos x by pi minus 2x, and at the point x equal to pi by 2 we will have the function as 3. Now we have to know the value of k. We are assuming the function is continuous, so left hand limit equal to right hand limit, and which is equal to the functional value at pi by 3 at x equal to pi by 3. So in the pi by 3 point, say for example we have a real line and 0, it goes up to infinity, and between 1 and 2. So assume we have the number pi by 2 here, and in the pi by 2 for the number we have, for any real number we will get as neighborhood. So neighborhood, right hand neighborhood will be pi by 2 plus h, left hand neighborhood will be pi by 2 minus h. Yes, now here the functional value is 3. So f of pi by 2 is 3. Now we can calculate either one of the limits. Let me calculate right hand limit. In the right hand neighborhood x will be pi by 2 plus h. Again, as x tends to pi by 2, h tends to 0. Now we will replace limit x tends to pi by 2 from right hand neighborhood. So k cos x divided by pi minus 2x. In this case we will replace x as pi by 2 plus h. So limit h tends to 0, k cos pi by 2 plus h, which is divided by pi minus 2 pi by 2 plus h. Now we can rewrite it as limit h tends to 0, k. So here cos pi by 2 plus h. Cos pi by 2 plus h means it is in the second quadrant. In the second quadrant we know cos 90 degree plus x will be minus sin x, because in the second quadrant sine and its inverse alone positive. Since we have odd multiple of pi, this cos ratio will turn into sine, and sine will be negative, because in the second quadrant cos sine and its inverse alone positive and the rest are negative. So based on that, cos pi by 2 plus h can be written as minus sine h divided by pi minus, after taking this minus 2 inside we will get minus pi minus 2h. Okay, now we can rewrite that as this is okay. Limit h tends to 0, okay, we are taking minus here, sin h divided by pi gets cancelled, so we will remain with minus 2h. So minus gets cancelled, limit h tends to 0, k by 2 sin h. We can rewrite the expression like this. Now this k by 2, which is independent of h, so limit does not affect that value, so we are taking that out, and we will write that expression as limit h tends to 0 sin h by h. Now we will apply sandwich theorem. According to sandwich theorem, limit x tends to 0 sin x by x is equal to 1, right? So k by 2 limit h tends to 0 sin h by h will be 1. So k by 2, we got right hand limit. So this right hand limit will be equal to the functional value. Only then the function will be continuous. So we are taking the function as continuous. So this k by 2 limit is equal to the functional value. Functional value is 3. So k value is 6. So the possible value of k is 6, so that the function is continuous at pi by 2. With this we are done with this problem. Thank you.